So let's now consider a non-linear model, non-linear first order ordinary differential equation model. So suppose a student carrying a flu virus returns to an isolated college campus of 1000 students. If it is assumed that the rate at which the virus spreads is proportional not only to the number of infected students but also to the number of students not infected. So determine the number of infected students after 6 days if it is further observed that after 4 days 50 students are infected. So in this case we have to see that the rate at which the virus spreads, that means if the number of students infected are x, so the rate of the infection will be dx over dt, and then that is proportional to x, and also those students which are not infected. So the total population is 1000. So if x are infected, so not infected are 1000 minus x. So the product of this, so dx over dt is proportional to x, dx over dt is also proportional to 1000 minus x. So to remove this proportionality symbol, so we introduce a proportionality constant k. So dx over dt is equal to k x 1000 minus x. So this is the differential equation in this case. So now we have to find the how many infections are there after 6 days, given that the infection after 4 days are 50. So for this we need to find x. So x4 is 50, so this is the initial value problem. Or we also know that another problem, initial value problem, that initially there was one student infected. Okay, at that time initially there was one student which was infected. So for this we need to solve this equation. So this equation can be solved by the separation of variables. So we can write it like this: x into 1000 minus x is equal to k times dt. So all x terms are over here on the left hand side. So this term is 1 over x into 1000 minus x. So we can write this term as partial fractions. Okay, so it will be 1 over x minus 1 plus 1000 minus x. So in this case we need to divide it by 1000, and then if you will simplify it, it will be like this. So this you can just verify by yourself. So k times dt. So now we can take 1000 on the other side, and we can integrate both sides. So 1 over x integration, it will be log of x, and 1 over 1000 minus x, it will be minus log of 1000 minus x. Because minus sign will be from the chain rule, so it will be minus log, and then this 1000 goes to that side, so it will be 1000 k dt, it will be kt, and then plus constant. So if I simplify it, so it will be log of x over 1000 minus x equal to this same value, tk or kt plus c. And then if I remove the log from this side, so it will be 1000 minus x e power 1000 KT plus C. So C we can bring here, and then we further simplify it, so it will be X will be equal to this 1000 C e power 1000 KT, and then minus X C e power 1000 KT. So from here I can find X is equal to 1000 C e power 1000 KT divided by 1 plus C e power 1000 KT. Okay. So this is the general solution. Apply the initial value problem. At time 0 there was 1 infection, so I can put X is equal to 1, and this will be 1000 C. This term will be e power, because t will be 0, so this term will be 1, and then e plus 1 plus C, and then this term will again e power, this will be equal to 1. So simplify it, so it will be 1000 C is equal to 1 plus C, so C will be equal to 1 over 999. Okay, so the equation, the general equation will become like this: X is equal to 1000 times 99. Okay, so it will be 1000 times 1000 divided by 199. Okay, so it will be 1000 divided by 999 times e power 1000 80 divided by here 1 plus 1 over 999 times e power 1000 80. So after simplification, this will be 1000 over 999 e power minus KT. Okay, we can simplify it in this form, and then now we can apply the second condition, because after 4 days there were 50 infections. Okay, so I put t is equal to 4 and x is equal to 50 into this equation. So x is equal to 50, 1000 over 999 e power minus k times 4. So from here the value of k, if you will simplify it, you will get the value of k will be equal to minus 1 by 4 log of 19 over 999. So in decimal form it will be 0.9906. So it will be a positive value, because this negative will, when multiplied with this value which of log, will be also negative, so it will be a positive value. So now we have to find how many infections after 6 days. That we need to find, because we already know the value of k into this equation. So x for 6 days will be equal to 1000 divided by 999 e power minus 0.9906, and then times t is equal to 6. So now you have to give some trouble to your calculator, and then you will see that about 276. So there will be about 276 infections after 6 days. However, if it continues like this, ultimately the infections will not be more than 1000, like this equation. So as the time will pass out, uh, as the time will pass, so the rate of infection will keep decreasing. So this graph can be plotted against time, and then we can see that this question is from chemical engineering. A compound C is formed when two chemicals A and B are combined. The resulting reaction between the two chemicals is such that for each gram of A, 4 gram of B is used. It is observed that 30 gram of the compound C is formed in 10 minutes. Determine the amount of C at time t if the rate of the reaction is proportional to the amount of A and B remaining, and if initially there are 50 gram of A and 30 crude gram of B. How much of the compound C is present at 15 minutes? So in this question, you have two compounds A and B, and these compounds are converted into C. Okay, so the amount of A plus amount of B should be equal to C. So A plus B is equal to C, and it is also said that for each gram of A, 4 gram of B is used. So which means that B is the one which is used 4 times more than A. So it means that 4 times more than A means 4 times A will be equal to B. Okay, will be equal to B. So in this case, if you see a compound, the amount of A is A, amount of B is B, and the amount of C is C. So you can see that the amount of C that will be produced, we can see that what will be the amount that will be produced in time t. So it means that if you represent dc over dt, so that will be the reaction rate. So this reaction rate will be proportional to what? Is proportional to the amounts of A and B remaining, not the A and B consumed, remaining. So what are the remaining amounts? So if, for example, the amount of A was initially A, okay, no, sorry, the total amount was 32, okay, and the amount consumed of A was A. So this means that it is said that the amounts of A remaining, if initially there are 50 gram of A and 32 gram of B are present. So it means that A was present as 52 and consumed was A. So the remaining will be 50 minus 32. 50 minus A. Minus A. And the remaining for B will be 32 gram of B was initially present and B gram was consumed. So this is what the statement says. So the amount of the rate of reaction is proportional to the amounts of A and B remaining. Okay. So we can introduce a proportionality constant over here. So this is the differential equation. So we can solve this differential equation to find the value of C. But here we have A and B are two variables. So from this equation, we can see that A plus B is equal to C and 4A plus B is equal to B. So if we put B is equal to 4A in this equation, so A plus 4A is equal to C. So it means that A will be equal to 1 by 5 of C. Okay. And therefore B will be equal to 4 by 5 of C. So dc over dt is equal to k into 50 minus 1 C by 5, and then it is equal to 32 into 4 by 5 C. The remaining in the next clip.